Welcome to our 7th video on our series on international macroeconomics. In this video, we're going to revisit the default model that we built on top of our small open economy model. This then builds on the models in videos 4 and 6 of the series. The objective of this video is going to be to conduct an exercise, which as we're going to see, it's going to differ a little bit from the model we had because we want to focus on how default affects not only the solution to the problem, but also can have effects on the interest rate that the countries pay. So let's get into it. First thing is this exercise is taken from problem set 3, so it should look familiar to many of you. The first thing we're going to do is we're going to deal with a two-period economy. The key difference here is that there is going to be uncertainty about future output, and I'm going to be clear about what that means in a moment. So we're going to first pose the problem without any default. Then we're going to derive and interpret the optimality condition with no default. We're going to see how default is going to affect the solution to this problem. To do that, we're going to introduce default when things go awry. When output is low, we're going to assume that the country can default on debt. And then we're going to see first how that modifies the optimality condition, what the effect of default is on the interest rate that the country has to pay, and what that implies for the equilibrium in this case. Okay, let's get into the problem. So this is the no default problem. We have a country that's choosing aggregate demand. And aggregate demand D, it's going to be equal to consumption plus government spending. Now, as I was saying a moment ago, the key difference here is there is uncertainty about the future. With probability P, output is going to be high. And with probability 1 minus P, output is going to be low. That's why there are two budget constraints for the second period. This is the budget if output is high. This is the budget if output is low. Now, because of this uncertainty about the future, the consumer, or in this case, the country, has to choose a plan for demand. So this is a bit different to the way we've done it in the past, but the math is exactly the same. What has to happen here is that the consumer chooses a demand for today and a contingent demand plan for each possible future. What that means is that you have to choose both a demand DH, that's going to happen if output is high, and a demand DL, that's going to happen if output is low. Now, how will this impact the optimality condition of the consumer? We can see here the optimality condition with no default. The left-hand side is very familiar to us, and it is the marginal utility of present demand. That's actually the marginal benefit of additional debt. What the consumer can do with additional debt is demand more today, and that additional demand is going to increase the utility of the consumer by 1 over D. Remember from the previous slide, utility is logarithmic, so 1 over D is going to be the marginal utility of consumption. The right-hand side is the expected marginal cost of paying for debt, and the key word here is expected. The consumer doesn't know which future it's going to face, and so when it's thinking about how to repay for debt, it has to think that with probability P, it's going to repay for debt when output is high. And in that case, it's going to have high demand. With probability 1 minus P, it's going to have to repay for that debt when output is low, D low. This 1 plus R is how much additional units of income the consumer has to pay. And this is how much that additional units of income the consumer has to pay is going to cost it in terms of utility. Now, notice that this condition only applies if the country can borrow freely, if there is no default. If there is default, as we've seen in the past, what's going to happen is there is going to be a borrowing constraint. And so B prime cannot be anything you want. It has to be lower than V over 1 plus RB, RB being the borrowing interest rate, the interest rate at which you can borrow. Now, how will this impact the solution of this problem? Well, you will have to first think of what will happen if I could just borrow freely. That will imply getting your budget constraints from the previous slide, replacing in D, DH, and DL in terms of bonds, in terms of debt, solving for B prime. If the solution satisfies the constraint, then you found it. But if it doesn't satisfy the constraint, then the consumer, or in this case the country, it's going to be constrained, borrowing constraint. And that means that you cannot have a B higher than this number. You want it, so you're going to have a B equal to this number. Okay, So that is what happens when there is no default with the budget, with the optimality condition, and a brief overview of what will happen if there will be default. But to see the effects of default on the interest rate, we're going to specialize, we're going to simplify a little bit the problem. Here's what we're going to do. We're going to assume that the country will default for sure if output is low. This is going to have two effects. The first effect is that the country now only needs to choose demand today, demand if output is high, and the debt. We don't need to choose demand if output is low because we know what that's going to be. You're going to default on your debt and you're going to get the low output net of the cost of defaulting. Now, because we're choosing a different bundle, we need a new optimality condition. We're going to do that in the next slide. The second thing that's going to happen is that international lenders are going to internalize the fact that default can happen with probability 1 minus p. And because default can happen, that's going to affect the borrowing rate. We're going to find that out by looking at lenders' profits. And we're going to see how, looking at the equilibrium in the lending market, we can get an expression for what the interest rate is going to be. So let's do that. The first thing is to pose the problem with default. Remember, it's the same problem we had before, just that now if there is default, this is going to be how much the country can demand. This is the same budget constraint we had before for the present period and for the case of high output. The optimality condition is very similar than the one we had. The only difference is that when we do the expected cost of getting the debt, we know that with probability 1 minus p, that cost is 0 because you're not paying. And so in this case, what we're going to have is just with probability p, we're going to have a cost of 1 over dh. How do we solve for this? Well, we can replace from the budget constraints for d and dh and get an expression that only involves b prime. Once we do that, we can solve for that expression and get the following expression for b prime. This essentially solves our problem because the other variables are a function of b prime by means of the two budget constraints. So this is the solution to the problem for the country given some interest rate. Now we're not done solving the model because we still need to know what's going to be the value of this interest rate. For that, we turn to the problem of the foreign lender. Now here are the profits of the foreign lender. There are payments for debt. So if the country repays with probability p, the lender gets back these payments. With probability 1 minus p, there are no payments. Simply the lender gets nothing back. And with probability nothing, with probability 1, sorry about that, the lender has to pay the deposits. And they pay deposits at the international interest rate R star. Notice here something that's been kind of lying low in our problem so far. The lending interest rate or the borrowing interest rate for the country can be different than the international interest rate. What we're going to see in this slide is that the relationship between the two is given by the probability that the country can repay. Okay, now we're going to find out that it is optimal for the lender to lend all deposits. Deposits are costly and they only generate revenue if they are lent to others. And so deposits are going to be equal to B prime. That's an optimal condition for the foreign lender. And when we replace this, we can find that the profits of the lender are actually linear. And what happens with these profits being linear, we've seen this before many times in the course, is that because of the zero profit condition, because of competition in this market, it has to be that these profits are zero. And so in equilibrium, the lending rate has to be such that these profits are zero. When we solve for this expression for the lending rate, RB, we're going to find that it is a markup over the international interest rate. Remember that P is less than 1. So this side over here is higher than R star. What that means is that the country cannot borrow at the same rate as the international interest rate because there is the risk of default. We can see that a bit more clearly because we're going to assume further that R star is equal to 0. And so RB only reflects the probability of default, 1 over P. Notice that if P was equal to 1, so in that case there will be no default, output will be always high, Well, in that case, with no default, RB will be equal to R star. And so there will be no gap, there will be no premium charged to the country for its borrowing. Okay, the last step is going to be to take this solution for the interest rate and integrate it back here into our solution for the lending that is going to occur. So how much the country is actually borrowing given the equilibrium interest rate. When we replace that, we get a very nice solution for the debt of the country. What we see is that the country wants to get debt as a fraction of how much additional output there is between the future and today. This is a specific fraction, as we can see here in the next line. This fraction allows the country to have the same demand in the present period and if output is high. And that's what the optimality condition demands. Remember that 1 plus RB is equal to 1 over P. The P's cancel, and so DH is equal to D. That is achieved by having bonds, by having the debt be this specific fraction of the additional output that the country gets. Now we can use this and our solution for B to find exactly what demand is going to be in this case. The solution is also nice. We see that demand, both in the present and in the future, is going to be an average of current output and future output. This is what we call consumption smoothing. Basically, what we're doing is averaging the two outputs to get consumption to be the same across the two periods. We can also see that the higher P is, the higher the weight is on the output being high. Okay, with that we finish this video. In our next video, we're gonna change tracks. We're gonna study the problem of the model with production. And then in our last video, so the one after that one, we're gonna use that model to think about the effect of different international and domestic shocks on an open economy.